Hello students, welcome to the part 2 of the CE short circuit current gain concept. In the last video I completed the derivation of the CE short circuit current gain AI. Just I want to revise it. This is the CE short circuit current gain concept. First we consider the circuit with RL, the load resistor, then we shorted RL. We got this resultant circuit. And then we derived the current gain and we got the current gain like this. Mod AI is equal to HFE by root 1 plus F by F beta whole square. Now I want to explain the concept F beta, parameter F beta or beta cutoff frequency. See, what is this parameter F beta or beta cutoff frequency? It is the frequency at which the transistor short circuit CE current gain drops by 3 dB or 1 by root 2 times from its value at low frequency. Okay. Yes. First, I'll see the value of CE short circuit current gain at low frequency, or I can say at zero frequency. Actually, what is our AI? Mod AI is HFE by root 1 plus F by F beta whole square. Okay. At frequency is equal to 0 means at very low frequency. So if you keep F is equal to 0, what is your AI? AI becomes HFE. So this is the CE short circuit current gain at low frequency or zero frequency. Now at F beta, when F is equal to F beta, we'll see what will happen. When F is equal to F beta, just keep F beta in the place of F. So you'll get mod AI is equal to HFE by root 1 plus F beta by F beta whole square. Okay. So what is this? F beta by F beta gets cancelled. So you'll get HFE by root 2. So what is this? The current gain becomes or drops 1 by root 2 times from its value at low frequency. Okay. Suppose if you convert this AI in dB, what do you have to take? You have to take 20 log base 10 AI. If you take this HFE by root 2 becomes HFE value in dB means 20 log base 10 HFE minus 3 dB means HFE by root 2 in terms of dB means HFE decreases by 3 dB times. Okay, that will be when F is equal to F beta. So that is the concept of F beta. So at F is equal to F beta, the current gain decreases by 1 by root 2 times or drops by 3 dB. We derived F beta as, see this F beta? This is your F beta. So GB dash E by 2 pi of CE plus CC. GB dash E by 2 pi of CE plus CC. What is GB dash E? GB dash E can be written as GM by HFE. So F beta is totally GM by HFE of 2 pi of CE plus CC. Okay, so this is the formula of your F beta. Okay, so this is the beta cutoff frequency. It is the frequency at which the current gain at low frequency means HFE drops by 1 by root 2 or 3 dB if it is in terms of dB. The value is, and the formula is F beta is equal to GM by HFE of 2 pi into CE plus CC. Okay, then we'll move to another concept. Concept is parameter FT or gain bandwidth product. I'll write the definition. It is the frequency at which short circuit CE current gain becomes unity. Okay. It is the frequency at which the CE short circuit current gain becomes unity. What is AI? HFE by root 1 plus F by F beta whole square. Okay. So now at this frequency Ft, it is the frequency. At this frequency Ft, your AI is becoming 1. So at F is equal to Ft. 1 is equal to HFE by root 1 plus Ft by F beta whole square. It implies 1 plus Ft by F beta whole square is equal to HFE square. Okay. Ft by F beta whole square is very greater than 1. Therefore, it implies you can neglect 1. So, Ft by F beta whole square is equal to HFE square. It implies Ft is equal to F beta into HFE. Or you can write Ft as HFE into F beta. Why it is called gain bandwidth product? What is the gain here? The gain is HFE. This is gain. This is called bandwidth. What is actually bandwidth? Bandwidth means it is the difference between upper cutoff frequency and lower cutoff frequency. Okay. What are upper cutoff frequencies and lower cutoff frequencies? Upper cutoff frequency and at lower cutoff frequency, the gain drops by 1 by root 2. 1 by root 2. Or if it is in dB, it decreases by 3 dB. Okay. Suppose if I draw the graph, take it as the gain AI on y-axis and it is the frequency. When the frequency is 0, what is the value? The value of maximum gain is HFE. At Ft, so at 0 frequency, you are getting the maximum gain. You don't have lower cutoff frequency at which the gain decreases by 1 by root 2. So how is your frequency response now? If you don't have the lower cutoff frequency, at low frequency the gain is high means the response is like this. The response is like this. Okay. And if it is HFE, there may be HFE by root 2. It may be the value HFE by root 2. It is the frequency. It is the frequency. What is this frequency? HFE by root 2. The corresponding frequency for HFE by root 2 is F beta. Means at F beta the gain decreases by 1 by root 2. Then what about your Ft? Ft means the gain is 1. Here it may be the 1. If it is 1. So this will be Ft. Okay. So now see. You don't have lower cutoff frequency. Actually bandwidth means FH minus FL. Upper cutoff frequency minus lower cutoff frequency. For this frequency response you don't have FL. So your FH becomes your bandwidth. What is FH here? At upper cutoff frequency or lower cutoff frequency, the gain decreases by 1 by root 2 times from its low frequency value, from its original value. Fine. So what is the value here? So what is the frequency at which the gain decreases by 1 by root 2? Your F beta. So that is the reason for us, FH is F beta. So that is the reason this Ft is called gain and bandwidth product. Okay, I think you understand. Now, see, on the y-axis we have taken AI. If you take AI in dB, suppose AI and dB, this all becomes dBs. Then this HFE is the maximum dB. This becomes the 3 dB gap if it is dB. If you take this axis as dB axis, this becomes 3 dB. Okay. How to get AI and dB? 20 log base 10 AI. Okay. So this is about the parameter FT. So totally FT is called gain and bandwidth product. This completes totally the CE short circuit current gain concept. So in the last video and in this video, we covered many things. First, I derived the current gain AI, and from that AI, I defined two parameters, the beta cutoff frequency and the gain bandwidth product FT. Okay, thank you very much.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.